Despite the fact that the James Webb Space Telescope has only been in use for a little over 2 years, it has made significant progress. Analysts have recently revealed the telescope's full potential, and you'll be amazed to learn just how powerful humanity's latest creation is. In fact, it might have recently found life on another planet. How powerful is the James Webb Telescope, and has it finally discovered life on a distant exoplanet? Prepare to learn all of this and more. The James Webb Space Telescope was launched in 2021 and has since been observing the most distant regions of the universe for signs of life and possibly advanced extraterrestrial civilizations. It has also been examining the atmospheres of nearby exoplanets to search for gases released by biological life or biosignatures, as well as chemicals that might be produced by these extraterrestrial civilizations. However, scientists were uncertain if the telescope could actually achieve these critical technological feats. As a result, they decided to test the James Webb Space Telescope's ability to detect intelligent life from Earth, the only known habitable and inhabited planet. In a recent study, researchers collected a spectrum of Earth's atmosphere and deliberately distorted the data to simulate the telescope observing Earth's climate from a significant distance away. Using a computer model that adjusted JWST's sensor capabilities, they analyzed whether the spacecraft could detect important technosignatures like nitrogen dioxide and chlorofluorocarbons, as well as biosignatures like oxygen and methane, which are released by biological life on Earth. The research team found that the altered dataset would be equivalent to the James Webb Space Telescope observing Earth from the TRAPPIST-1 star system, which is located roughly 40 light-years away. The results were surprising. The telescope should be able to find evidence of extraterrestrial life within 40 light-years of Earth and might even be able to find such evidence up to 50 light-years away. However, a recent and fascinating discovery may significantly demonstrate that, if life existed anywhere across the Milky Way, the telescope could detect it. The planet K2-18b, which was discovered recently, is around 120 light-years from Earth. The exoplanet is about 2 to 3 times larger than Earth and has 8.6 times Earth's mass. Because it is a high-shine world, there is likely a liquid water ocean on its surface and a significant concentration of hydrogen in its atmosphere. The JWST detected carbon dioxide and methane while analyzing the atmosphere of K2-18b. This is an astonishing revelation in itself, but it's not what makes the discovery particularly captivating. Dimethyl sulfide, DMS, a chemical present on Earth, could exist on this extraterrestrial planet. Since DMS is only produced by life on our planet, it is particularly intriguing. It is often produced on Earth in marine environments by phytoplankton, a tiny organism that resembles plants. Because of this, DMS may represent a biosignature, something that has never been found on an exoplanet. Astronomers used to focus mainly on rocky planets when searching for evidence of life. However, ocean-covered planets, known as Hycean planets, with hydrogen atmospheres are believed to be more promising as candidates for extraterrestrial life. These planets are more suitable for atmospheric studies. This is likely due to the fact that the vast majority of exoplanets that have been found differ greatly from Earth. It's not yet clear to scientists whether dimethyl sulfide is present on K2-18b. We need more data to confirm these results, as the JWST hasn't had much time to observe the exoplanet. We will soon determine whether significant amounts of DMS are present on K2-18b. Even then, we can't be certain that life exists on this Hycean planet. Biosignatures are challenging to study for various reasons. Our primary reason for studying them is our understanding of Earth's environment. Another issue is that biosignatures are not limited to living things. They could originate from other sources as well. Take oxygen, for example. Although it is produced by plants and algae on our planet through photosynthesis, it can also come from purely geological or non-biological processes, such as the breakdown of oxygen-containing minerals or the result of chemical reactions involving oxygen-rich substances. We are undoubtedly making progress. Initially, we focused on finding planets with sizes similar to Earth's. Next, we added the habitable zone to our list of criteria, which allows the presence of liquid water. We are now delving much deeper into exploring the chemical makeup of exoplanets. We can currently use a technique known as atmospheric spectroscopy to detect biosignatures on extraterrestrial worlds. Even at this exceptional stage of technological advancement, researchers are finding novel approaches for detecting biosignatures on exoplanets. Some of these methods may even be capable of describing the presence of extraterrestrial life forms. In one study, scientists examined the Archean period of Earth's history, which was home to a wide variety of early life forms, including purple bacteria, to determine if Earth's appearance from a distance would change if such life forms were widespread. Various simulations were created, including factors such as the presence and thickness of clouds in the atmosphere at the time of observation, as well as the amount and distribution of bacteria in both marine and terrestrial habitats. The study's findings were exciting. Purple bacteria stand out in a particular range of colors due to their unique ability to reflect light. This is similar to the red edge phenomenon, characterized by a sudden increase in near-infrared reflectance in green vegetation found in leafy plants. However, this rise occurs in a somewhat different color range for purple bacteria. The bacteria's peculiar colors and ability to absorb light give them their surprising quality. They are better able to absorb and use light to meet their energy needs. If an exoplanet's skies don't get much cloud cover and its surface contains a lot of purple bacteria, we might be able to use specific optical filters to find evidence of these species. Indeed, the James Webb Space Telescope has recently released several fascinating new discoveries. However, these aren't the only revelations the telescope has made this year. The next one has sparked much debate and discussion. All matter is drawn together by the attractive force of gravity, and our universe is expanding. Physicists used to think that this expansion should eventually slow down. However, we've also found that the universe's expansion is accelerating. If we only considered conventional matter, nothing would make sense. Therefore, there must be another factor involved. At that point, scientists began to hypothesize about the existence of dark matter and dark energy, two perplexing substances that dominate the universe. Dark matter, like an invisible material in space, holds galaxies and clusters of galaxies together. It makes up 27% of the universe and functions as a sort of underground structure that keeps everything together. It doesn't emit light and doesn't interact with ordinary matter, but its gravitational fingerprints allow for further study. An additional puzzling phenomenon is dark energy. It is responsible for the universe's accelerated expansion and comprises roughly 68% of the universe. We can determine its amount by observing the patterns and movements of galaxies. Scientists have taken meticulous measurements of things like cosmic background radiation and the overall structure of the universe, which has allowed them to realize its presence, even if humans can't see it or touch it. Astrophysicists needed proof of the existence of dark matter or dark energy until recently, but that might have changed. Nuclear fusion is the process that powers stars, including our sun, at their cores. The process of nuclear fusion is the combination of lighter elements, such as hydrogen, to produce heavier elements, primarily helium. The enormous amount of energy released during this process gives stars their stunning brightness in the vastness of space. This energy is released as heat and light. However, dark matter, or more specifically, the heat generated during its self-destruction, may offer an alternative source of energy for stars. The telescope might examine some of the universe's most distant regions with the JWST's Advanced Deep Extragalactic Survey, essentially looking into the past. Moreover, because the early universe was completely different from what it is today, extraordinarily odd celestial bodies, like stars hundreds of times more massive than those forming today, existed back then. 4 stars, Jades, GS-Z10, Jades, GS-Z11, Jades, GS-Z12, and Jades, GS-Z13, were discovered. Jades, GS-Z11, Jades, GS-Z12, and Jades, GS-Z13 are some of the most distant celestial bodies ever identified. These stars are not just any stars, though. Astrophysicists hypothesize that Jades, GS-Z11, Jades, GS-Z12, and Jades, GS-Z13 are hypothetical dark stars because they might be powered by dark matter. These stars are incredibly bright, perhaps 1 billion times brighter than the sun and millions of times more massive, despite being referred to as dark stars. According to scientific theories, Dark stars formed in regions rich in dark matter, created when helium and hydrogen clouds collapsed shortly after the Big Bang. Supersymmetry, a theory in physics, may explain how such stars are created. Imagine the early universe as a cosmic kitchen. The formation of dark stars occurred when clouds of hydrogen and helium, remnants of the Big Bang, combined. These stars began to cook. Dark matter particles might now resemble cosmic twins with separate supersymmetric partners, with a unique property known as supersymmetry akin to matter-antimatter annihilation. When they collide, these particles disintegrate, releasing a burst of energy. As a result, other particles, including photons, electron-positron pairs, and neutrinos, are formed. Neutrinos, which barely interact with anything, escape the cloud, leaving behind energy while other elements remain inside and interact. Neutrinos impart their energy to the helium and hydrogen in the cloud as they collide with it. This energy transfer heats the cloud, causing dark stars to form. Some of these stars could have 1 billion times the brightness of our sun. However, some are only a few thousand times brighter. These stars eventually die after consuming all their fuel. However, this new research also reveals that dark matter-powered stars would differ significantly from our sun and other contemporary stars. Given their incredible brightness, they might be visible to distant planets in other galaxies as light sources. However, unlike other stars, they would not produce significant amounts of metals, and because they cannot burn, they are unlikely to produce iron, carbon, or oxygen. Instead, it would eventually break down into a supermassive black hole as it burned all the helium and hydrogen. We still don't know much about these strange stars. However, it's possible that the James Webb Space Telescope has already made a discovery that could redefine our understanding of stars. We are currently dealing with new problems as the scientific community works to validate these findings. The James Webb Space Telescope has made many extraordinary findings, and we still don't know what else it will uncover as its sensors continue to peer into the most distant corners of the universe. We eagerly anticipate many more exciting revelations from JWST.